Welcome to the introduction course for MongoDB offered by Saint Hua. For today, we will be covering the introduction of MongoDB, MongoDB concepts, and basic CRUD operators. So, what exactly is MongoDB? In short, it's a NoSQL database, meaning it doesn't follow the traditional table-based structure of relational databases. Instead, it uses a flexible document-based model. This allows for high-speed queries and agile development, as data can be easily modified and expanded without the constraints of a rigid schema. While this approach may require slightly more storage, the abundance and affordability of storage in the modern day make this trade-off increasingly advantageous. This flexibility is a perfect fit for the rapidly changing requirements of modern applications. MongoDB runs on a variety of platforms and supports integration with many coding languages, making it a versatile choice for developing applications across a wide range of devices, from mobile phones to desktops. Lastly, MongoDB offers a community edition that is open source, providing developers with a powerful and free database solution. Its architecture is designed to be scalable, flexible, and high-performing, making it a perfect fit for the diverse and evolving data needs of modern applications. Let us compare relational and non-relational databases. Relational databases, like MySQL or PostgreSQL, are like meticulously organized filing cabinets. They store data in tables, with each row representing a record, and each column a specific attribute. This works incredibly well for structured data with well-defined relationships, like customer information or financial transactions. On the other hand, non-relational databases like MongoDB are more like flexible containers. They store data as documents, which are self-contained units similar to JSON objects. This is a perfect fit for unstructured or semi-structured data, where relationships may be less rigid or more complex, like user activity logs, product catalogs, or social media posts. Think of it this way. Relational databases are like spreadsheets with a strict format, while MongoDB is more like a collection of notes, each with its own unique content and structure. This flexibility makes MongoDB a powerful tool for handling the diverse and ever-changing data needs of modern applications. MongoDB offers several key advantages over relational databases. Unlike traditional relational databases that require rigid, predefined structure, MongoDB's flexible scheme allows you to easily adapt to changing data requirements. You can add new fields, remove existing ones, or even change the types of data stored within a document, all without having to redesign your entire database. This agility is a game changer, especially when dealing with evolving applications or unpredictable data sets. MongoDB is also known for its exceptional performance in reading and writing data. This is partly due to its use of BSON, a binary format for storing documents, which allows for efficient data retrieval. MongoDB's architecture, which can be scaled horizontally across multiple servers, also contributes to its ability to handle large volumes of data and high traffic loads without sacrificing speed. MongoDB's query language offers a robust set of capabilities, allowing you to perform complex searches, aggregations, and data transformations directly within the database. It supports a wide range of operators for filtering, sorting, grouping, and projecting data, giving you the flexibility to extract meaningful insights from your documents without the need for extensive application-level processing. MongoDB is designed to scale both vertically and horizontally, meaning you can vertically scale by increasing the resources of a single server, or horizontally scale by adding more servers to your cluster as your data and traffic grow. The flexibility and sharding ability allows MongoDB to handle massive amounts of data and high user traffic without sacrificing performance. making it a true powerhouse when it comes to dealing with the demands of modern, data-intensive applications. Lastly, with a vast and active community of developers, MongoDB boasts a thriving ecosystem of tools, libraries, drivers, and resources. This means you'll have access to extensive documentation, tutorials, forums, and support channels to help you troubleshoot issues, learn best practices, and accelerate your development process. Whether you're a beginner or an experienced user, the MongoDB community is there to support your journey. If you're just starting out with MongoDB, the easiest way to get hands-on experience is through MongoDB Atlas, their fully managed cloud database service. Atlas takes care of all the server setup and maintenance for you, so you can focus on building your application. Creating a free Atlas account is a straightforward process. Simply sign up, select your preferred cloud provider and region, and you'll have a MongoDB cluster up and running in minutes. This free tier is a great way to explore the features and functionality of MongoDB without any upfront investment. MongoDB Atlas also allows you to set customizable roles and permission. You may pause the video now if you want to sign up for a free MongoDB Atlas cluster and explore the interface and functionalities. Be sure to select Yes for including the inbuilt sample data sets if you want to follow the hands-on in the later part of lesson. After setting up your MongoDB Atlas cluster, the next step is to establish a connection to it. Think of this like getting the address and directions to a new house you want to visit. In the MongoDB world, that address and set of directions is called a connection string. A connection string is essentially a URL-like string that tells your MongoDB client a specific application that interacts with the database on how to reach your database. It contains key pieces of information. You can easily find and copy the connection string for your cluster within the MongoDB Atlas interface, usually under the Database Access or Connect section. To interact with your MongoDB databases visually, you can use a graphical user interface tool. MongoDB Compass is a free and powerful GUI designed specifically for MongoDB. It provides an intuitive way to visualize your database's structure, explore your collections and documents, build queries, analyze query performance, and even manipulate your data directly within the interface. It's a fantastic tool for beginners and experienced users alike, offering a user-friendly way to interact with your MongoDB environment. Lastly, you can interact directly with your MongoDB database using its built-in shell. This powerful command line interface allows you to execute queries, perform administrative tasks, and even write JavaScript code to automate complex operations. While GUI tools like MongoDB Compass offer a visual way to interact with your data, the shell provides a flexible and efficient way to manage your database at a lower level. To navigate through different databases from the sample data using Mongosh, simply type in use followed by the database name in the command terminal. Once you are at the database of interest, use db. Followed by the collection name to perform your operations. Let's talk about the backbone of database interaction, the CRUD operations. CRUD stands for Create, Read, Update, and Delete. Let's take a moment to understand their fundamental role in data management. Whether you're working with a traditional relational database or a modern NoSQL system like MongoDB, CRUD operations are the building blocks of how you interact with your data. They are the core actions that enable you to create, read, update, and delete information, forming the basis for virtually all database interactions. Each of the four CRUD operations serves a unique and essential purpose. Creating new records or documents populates your database with information. Reading data allows you to retrieve and display that information to users, or use it for analysis. Updating data ensures that your records remain accurate and up to date. And deleting data allows you to remove obsolete or unnecessary information, maintaining the integrity and efficiency of your database. CRUD operations are not limited to databases alone. They are fundamental to the operation of virtually any software system or application. From content management systems that allow you to create and edit web pages, to customer relationship management tools that track and update customer information, CRUD operations are the underlying mechanisms that make these systems work. A deep understanding of CRUD operations is crucial for any developer or data professional. It allows you to design and build efficient, robust, and user-friendly software solutions. In the context of MongoDB, mastering CRUD operations will empower you to harness the full potential of this flexible and scalable NoSQL database. Now that we've established the significance of CRUD operations in data management, let's dive into how MongoDB empowers you to perform these operations with ease and efficiency. We'll begin with creating data, the C in CRUD. In MongoDB, you have two primary methods for inserting data into your collections: insertone and insertmany. The insertone method is your go-to tool when you need to insert a single document. You simply pass in the document you want to add as a JSON-like object, specifying the fields and values. If you have a batch of documents to add, insertmany comes to the rescue. This method accepts an array of documents, allowing you to insert multiple records in a single operation. Just like insertone, you can include an options parameter for additional control. Remember that each document you insert should follow a valid structure with key-value pairs. MongoDB is flexible about data types, so your values can be strings, numbers, booleans, arrays, or even nested objects. I am sure you are eager to write your first query with MongoDB, but before that, here are some tips for you to keep in mind. While MongoDB's flexibility means you don't have a strictly enforced schema like in relational databases, it's still highly recommended to plan out a consistent structure for your documents. This standardized schema design makes it easier to query and analyze your data, especially as your database grows. In addition to a consistent schema design, consider how you'll manage unique identifiers for your documents. MongoDB provides a special field called _ID to uniquely identify each document within a collection. You have a few options when it comes to this field. You can simply let MongoDB handle it. If you don't explicitly provide an _ID field in your document, MongoDB will automatically generate a unique object ID for you. Alternatively, if you have a natural unique identifier in your data, such as an email address or a product SKU, you can use that as the _ID. In some cases, you might have specific requirements for your unique identifiers. In those situations, you can create a custom generator to craft your own unique _ID values. No matter which approach you choose, including a unique identifier field is essential for easily referencing and retrieving specific documents within your MongoDB collection. It's time for some practice. The first task for you is to create a brand new database call shop and create a candy shop collection in the database. You can use both Compass and Minx Terminal to add some candies into your collections. You may include information like candy name, unit price, calories per serving, and so on. Good luck! Your second task is to use Compass and Mongosh to create one document each in the sample training database. Grades collection. You may or only assign 4 scores corresponding to exam, quiz, and 2 homeworks. Be sure to study the schema structure in the collection. Note that the scores are in the data type of key and value pair arrays. You may pause the video now and practice document creation. Welcome back. Let us move on to the read operation. To retrieve documents from your MongoDB collections, you utilize the find method. Think of it as your search tool within the database. The find method allows you to specify query conditions to filter the documents you want to retrieve. These query conditions are similar to the where clause you might be familiar with in SQL. For example, if you have a collection of user data, you could use find to retrieve all documents where the age field is greater than 30. MongoDB provides a rich set of query operators to express a wide range of conditions, including equality, comparisons greater than, less than, range queries, and even text searches. You can also combine multiple conditions using logical operators like and, or, and not to create more complex queries. The find operator is powerful, but it becomes even more versatile when you combine it with query operators. These operators let you precisely target the data you need. For instance, the GD function filters the database to only return documents with field having a bigger value than the specified. Note that these operators need to have a $sign in front as syntax requirement. Experiment with these and other query operators to unlock the full potential of the find function. Now that you're familiar with finding documents in MongoDB, let's explore a powerful technique called projection. In real-world databases, documents can become quite large, containing a wealth of information across many fields. However, not every query needs every single detail. Fetching entire documents unnecessarily can consume bandwidth, making your application slower and less efficient. Projection steps in to streamline this process. By specifying which fields you want to include or exclude, you can drastically reduce the amount of data transferred between the database and your application. This not only makes your queries faster, but also saves precious resources. The syntax for projection is quite simple. When you use the find method, you provide two arguments: the query to filter documents and a projection document. Simply specify a field and set the projection as 0 or 1, allow you to choose what appears. Now, let's take your MongoDB queries to the next level with sorting and limiting. The sort method is your key to sorting. You simply specify a document where each field represents a sorting criterion. For each field, you assign a value: 1 for ascending order or -1 for descending order. You can sort on multiple fields, giving you flexibility to create complex ordering schemes. For example, you could sort products first by category, then by price within each category. The limit method is your tool for limiting. You simply pass it the maximum number of documents you want to retrieve. This can be particularly useful when dealing with large data sets, allowing you to quickly grab a sample or view the top-ranking items. Let's practice finding some documents. Navigate to Sample Airbnb and using the Listing and Reviews collection. Your objective is to find out the top 5 Airbnb's name that has most number of beds. If you are up for some challenge, you may navigate to the Planets collection in Sample Guides database and find out which planet or planets has CO2 as part of their main atmosphere. What are their orders from Sun respectively? You may pause the video now and practice at your own time. Welcome back to the update section of CRUD. In the real world, data isn't static. Customer information changes, product inventory fluctuates, and user preferences evolve. MongoDB's update operations empower you to keep your data up to date and aligned with the ever-changing nature of your applications. MongoDB offers two primary methods for updating documents. Update 1 for single document change, and update many for bulk changes. Both function takes in two arguments. First being the condition, and second will be the changes to be made. The most common change operator to use will be the set operator. The update function you provide is the heart of the operation. It describes the modifications you want to make. Here's where MongoDB's update operators shine. The set operator sets the value of a field to a new value. The inc operator increments or decrements the value of a numeric field. The push operator adds an element to an array. A pull operator removes elements from an array that match a specified condition. The unset operator removes a field entirely from a document. MongoDB offers many more update operators to cover various scenarios. Here comes another practice time. Using the same Airbnb database and listing and reviews collection, change the number of beds for nice room in Barcelona Center to 4. If you want to challenge yourself further, you can go to the sample restaurant database, restaurants collection, and change the grade that restaurant Nordic delicacies receive on the year of 2013 to B instead. You may pause the video now. We are at the last section of the CRUD operations. As your applications evolve, you might find that certain documents in your MongoDB collections become obsolete or no longer relevant. This is where delete operations come into play, allowing you to remove unwanted data and maintain a clean and efficient database. Similarly, MongoDB offers two primary methods for deleting documents as well. Delete 1 for single document removal and delete many for bulk deletion. Different from the update functions. The delete function only takes in one argument, being the filtered conditions. As there's nothing to be changed, you can specify query conditions to target the documents you want to delete. For example, if we were instructed to discard all records of user below age 20 due to a shift in target customer, we can do that using the delete many function. All documents that contains user under 20 years old will be deleted. Note that deleting documents is a permanent action. Be absolutely sure you want to remove the data before executing a delete operation. For our last practice, let's use the comments collection in sample mflix database. Your task is to delete a review written by John Bishop. When you are done with the first task, go to the movies collection in the same database and delete all movie records with George Barnes as one of the cast. You may pause the video now. We've reached the end of our introduction to MongoDB. But this is really just the beginning of your journey with this incredibly versatile database. You now have a strong grasp of its fundamental concepts, from understanding its document-oriented data model to performing essential operations like finding, updating, and removing data. These building blocks lay the groundwork for tackling more advanced scenarios and unleashing MongoDB's full potential. As you continue your exploration, you'll discover a wealth of powerful features waiting to be explored. Aggregation pipelines, for instance, allow you to transform and analyze your data in sophisticated ways. Indexing helps you optimize query performance, ensuring your applications are lightning fast even when dealing with massive data sets. And with careful data modeling, you can design schemas that perfectly match the unique requirements of your projects. Thank you for taking this course with us.